So we will have a down conductor that comes over the roof, that comes down here. Okay, it will come down here into the ground. Okay, and then in this ground, we're going to dig up the ground here to put our earth rods. Hi guys, welcome to Asher and Gad channel, making Africa home again, one family at a time. As usual, like, share, subscribe, hit the notification button if you're new to this channel so you always get notification of our videos, which tend to be every Tuesday and Friday at 6 p.m. GMT. All right, awesome. So on site again, and today I want to talk about lightning protection. Okay, what is lightning protection? Number one. Two, do you need lightning protection? Number three, what are the elements of lightning protection? What are our plans to have lightning protection on our site? Why we need them? The insurance implications, etc., etc. The how you can protect your electronic items, not just your structure, but also your electronic items against power surges when it comes to lightning protection. So, what is a lightning protection system? Simply put, a lightning protection system is a system that protects your building, as in the structure of your building, from a direct lightning strike. Okay, obviously, if your building gets struck directly by lightning, that's a significant risk. It can catch fire and it can destroy your building, a significant part of your building. So it's something that you need to consider. Then you ask yourself the question: what is the risk of a lightning strike? Well, you know, it happens all the time. Some areas are more prone to thunder and lightning than others, so there is a risk there. It's best to have it than not to have it. So there are some building insurance companies who will not insure the structure of your building here in Ghana and other places as well, in American places, if you do not have a lightning protection system in place. Okay, so that's something else you need to consider when building your structure. So if I'm going to explain a bit more about electrics as well. We learned in another video, when I did a video about the electric fence, okay, I talked about the fact that current flows from a high voltage to a low voltage, okay? Current flows from a high voltage to a low voltage. If you haven't watched our video on the electric fence, please click up here to watch that video. So in the same principle, how does the lightning protection system work? Now, the current is coming from the sky. We have positive electrons coming from the sky at a significantly high voltage, thousands of volts. So, as I said, lightning, the current flows from the high voltage, thousands of volts, to the ground, which is relatively at 0 volts. So it's trying to come down. It needs to come down. That's why, that's what's happening. So it's a high voltage trying to come down to a lower voltage, which is the earth. But what we need to do, the lightning protection system attracts the current from the lightning strike. It attracts it and directs it to the ground, okay, via its highly conductive path without damaging your structure. Okay, so that is what the lightning protection is about. Okay, it's attracting the high voltage current that's coming from the sky, as in the positive electrons, is attracting the current and directing the current through a certain path down into the ground where it wants to go. All right. If you don't have a lightning protection system, then obviously as the current is coming down, it will scatter and go wherever it needs to go, causing damage in its path, and that's what we're trying to avoid. So, what is a lightning protection system? What does it comprise of? There are three main parts. You have what we call the air termination network, which is on the roof. Then we've got the down conductors. Okay, I'm going to show you pictures of all of that. Then you've got the earth termination network. So there are three sections of a lightning protection system. Where we live, for example, has a lightning protection system in it. So let's start with the air termination network. The air termination network is always on the roof, okay? And what you have on the roof, you have something we call air termination rods, okay? I've got a couple of pictures on your screen, and this is where we live right now. You've got air termination rods, and the function of those air termination rods, as I said earlier, is made of copper. We know copper conducts electricity very, very well, so it attracts the current from the lightning to that air termination rod, okay? Now, the air termination rod, you have a couple of those in the corners, okay? Then you will have some tapes that run along the roof. That is all part of the air termination system. So that is the picture on your screen. You can see the spike the air spike or air termination rod, and you can see copper tapes running along the roof. Those two items form what we call the air termination network. Now, the copper tapes that run on the roof, they are generally 25 millimeters wide by 3 millimeters high, okay? And, you can keep them, ideally, normally the copper is in a PVC sheet. So you have a PVC sheet over the copper, and what you can do, you can color that sheet to match your building color. So it's not very obvious it doesn't sort of detract from the aesthetic appeal of the building. So that's the air termination network. So from the air termination rod, you also have what we call down conductors. The down conductors are also the same type of tapes, copper tapes, PVC covered copper tapes, 25 by 3 mil. They come down along your building, vertically down. Okay. Again, I'm showing you some examples from where we live right now. You can see those down conductors, those copper tapes that run vertically down your building. Okay, that is what we call the down conductors. Why are they called down conductors? Because they conduct the lightning current down into the ground, into the earth. Okay, so then we come to the earth termination network. So the earth termination network basically comprises of earth electrodes which are buried in the ground. I'm showing you a diagrammatic picture on your screen, and that is an example of an earth termination network. It's basically an earth rod or a couple of earth rods that is drilled into the earth that the down conductor will connect to drive the current into the earth. Okay, and basically those two rods will have a final cover to match your landscaping. So for example, let's look at our building here. So with our building here, okay, for those of you who know, what our roof looks like, in my design of my lightning protection system, I have a minimum of 2 air termination rods. I may make it 4. Still thinking that through. It's about a risk assessment. So we have the air termination network. We've got the horizontal tapes on the roof, and then we have the down conductors. One will come down here. Okay, so we will have a down conductor that comes over the roof, that comes down here. Okay, it will come down here into the ground. Okay, and then in this ground, we're going to dig up the ground here to put our earth rods. Okay, now, however, we're not going to put the final cover on yet until we do the final landscape, because the final cover must be level with the final landscape, in a similar way that the septic tank cover will be level with the final landscape, in a similar way that the borehole cover over there has a cover to it. Okay, so there'll be a cover to it, and you have sort of lightning protection or earth electrode written on it, so you know this is exactly where your earth termination network is. Okay, so that's what comprises of the lightning protection system.
One question.
Yes.
So that's the kind of earth you're talking about.
Yes.
So why didn't they dig the ground up at the same time they were doing the other one?
Yeah, good point. Yeah, they didn't do it because I didn't instruct them to. Basically, I didn't set aside finances for it at that point in time.
Right.
Yeah, because although it's important, there were other things that are more important.
Right.
That's why I didn't. But you're right. If you can do it all at the same time, that's even the best. That's the best thing.
Right.
But you're right. I didn't set aside finances for it because there was things that were of a greater priority. Some people take the risk and don't even put it in, but it's necessary to have it in. Okay. So we will dig the ground and put it in. Now that's not the end. Remember, this is an electrical system. So once you install it, you need to test it to make sure you have the right resistance. Okay. The resistance must be low enough for the current to be directed down into the ground. And generally, when your electrician does a resistance test, he needs to make sure the resistance to earth, okay, I'll confirm it on your screen, but I believe the resistance to earth has to be less than, I think it's half an ohm, either 1 ohm or half an ohm, okay, the resistance to ground. Okay, once he does that test, if the resistance to ground is less than that, then you know that you have a proper lightning protection system with a low enough resistance in order to direct the lightning current into the ground and protect your structure. Okay, remember, if you're going to get building insurance for the structure of the building, you need to make sure, check your terms of insurance, and if there's lightning protection requirement in there, then you need to have it, unless your structure will not be protected. Maybe your contents will be, but your structure won't be. Okay, right, this earth electrode is typically buried about, let's say, between 5 and 10 foot into the ground. But that will all depend on the resistance value. When you bury it and you measure the resistance and you're not getting the right low enough resistance to comply with the regulations, then you need to keep on going, or add more rods in parallel to get a lower enough resistance that will comply with the regulations. Again, I'm not sure what the regulations are in Ghana, so I'm going to base it on a UK value. Maybe those in Ghana who know what the value is can let me know in the comments below. The final thing I want to talk about before the rains come down, because they felt a bit drops on us a minute ago, is there are two things. There's to protect your building structure. God, it's hot here. Protect your building structure. There are two things we need to take into consideration. So there's protecting your building structure from a direct lightning strike. Then there's protecting your electrical system from an indirect lightning strike. Sometimes you can get a lightning strike that strikes the cables that you can see, the ECG cables, and then those cables can direct the impact or the voltage surge of that lightning into your home electrical system, which is why it is very important to have a surge protective device on the incoming section of your home electrical system, on the incoming section of your distribution board. As you know, we have an automatic voltage regulator which also can serve that same purpose. Yeah. So remember, from an indirect lightning strike, it's indirect because it strikes the electrical cable outside or any other service outside that's coming into your home and can damage your electrical equipment. That's indirect. A direct lightning strike is one that strikes your building directly. So to protect your electrical equipment, electronics from indirect lightning strikes, you need to have a surge protective unit or a surge protective device on the incoming side to your house electrical system, or have it integral to the AVR if you have one like we have. All right, let me just check my notes to make sure I've covered everything. Gad had a good question. That was a really good question. She caught me out there. I didn't expect that question at all, but she was right. You know, depending on your budget and your finances, at every stage, when you're digging the ground and you put in your main building earthing, your generator building earthing, and you know you're going to put a lightning protection system, and your budget, your priority and your budget will allow at that point in time, put it in at that point in time. That's the easiest thing to do. We obviously haven't done our permanent landscape, so it's still not a huge issue. This is all. There's no permanent landscape on here, so that is absolutely fine. We'll just dig it and put it in. All right. So that's it, really, guys. That's it. I just wanted to talk about lightning protection systems for those who don't know what that is, and just to make it more practical for you to understand what we are going to do, so you can understand what you need to do in your building to protect the structure of your building and to comply with your insurance if that is a requirement. All right. Well, hope you enjoyed this episode of Asher and Guide. As usual, like, share, subscribe, hit the notification button so you always be aware when we upload an educational video for your viewing pleasure. So from you, it's
Chemist here.
guys, Yebeshia. See you next time.